All right, let's get started. This time the computer is cooperating. So we're going to talk about the domain name system today. And I'm first of all curious, has anyone ever heard of DNS before? How many of you have taken, I think it's 317? All right, so some of this will be familiar to you. That is not a prerequisite for this course. So there is a fair amount of additional material that I've provided for people who are not familiar with this, including what started out as a very simple exercise and turned into about 25 pages of description. So I said, well, I gave you a learning prompt. Anybody use the learning prompt I gave last week? Did you try it out? Nope. I'll take that as a no. Great. Well, I actually used the learning prompt this morning. I said, well, you know, let's see, because I wanted to just illustrate one very small specific element, which is how you can set up something called a pie hole, which is basically your own controlled DNS server that allows you to change the way that you're tracked and actually to change the way that you experience the internet at large. How many of you have ever heard of a pie hole? A pie hole. It's literally named because it was originally implemented as a DNS server that ran on a Raspberry Pi. But these days, mostly we just run it inside of a container. It doesn't really matter. It's a DNS proxy server is what it is, because DNS is nothing but a whole series of proxy servers. So you'll see these themes keep recurring. In systems, we actually claim that we have lots of tools, and it turns out we really only have one, which is an extra level of indirection. We use it over and over and over again. Why do anything directly when you can do it through a table lookup? In DNS's case, why answer a question when I can have someone else answer the question for you? And then I'll just cache the answer so that it's faster next time. And it's a little tongue-in-cheek to say that, but there's a certain amount of truth to it as well. So let's talk about this. I'm still playing with slide technologies. It is actually PowerPoint. And the beautiful part about PowerPoint is that if you generate it using different templates, you can't merge things together very easily because there's like apparently no standard way of doing these things. So you have to basically rebuild all the slides. So you're going to see a few color changes here as I mix in different slide formats. Logistics, nothing really big there. I literally just changed the capstone pitch from today till Thursday because some people pointed out that despite my best efforts to stamp it out, it included only for the final project 2-week non-code deliverable extension. The idea was that's how I can set a deadline inside of the allowed parameters of UBC and yet still give you some flexibility to like try to work around everything else. The problem with trying to do that now is it means that it's really hard to get the grading done and back to you in time if there's a 2-week window. For the last assignment, nobody's going to care. If you get it on December 20th or you get it on December 30th, probably aren't going to really notice that much difference. So several people said that caused problems for them, and so the compromise was to push it out by 2 days. The disadvantage is that means the people who have procrastinated it are now stuck trying to balance two things between now and Thursday that are due. The people who have already done it, don't keep working on it. Move on to the next thing. That's a better use of your time. And maybe you haven't done either one of them, in which case, figure it out. Balance your time out. The TA office hours, as far as I know, haven't changed. The biweekly check-in I moved because I'd moved the Thursday deliverable. You can't really comment about the thing that was supposed to have been turned in on Tuesday on Thursday, so I pushed it out till next Tuesday. See how these things start having impact like that, unfortunately. This was the prompt that this is the general form of the prompt that I recommended last week. This is what I actually used. I said, if you don't know, you walk into a class, you don't know about the domain name system, how do you educate yourself because you will increasingly find that this happens to you over and over again in the real world, not just in academia, but when you have work and somebody says, they come to you and they start blathering about some technology and you're like going, what the hell are they talking about? Has anybody ever had this happen to them? You get into a conversation and people start using terms and you're like, I don't know what you're talking about. How do you get yourself up to speed quickly so you don't look like an idiot and you can actually contribute to those discussions? Because of course, you know, this is your first job. You just managed to land this thing by the skin of your teeth and you don't really want to lose it because you don't want to have to go and explain to your parents why it's living with them or living in a tent as the option. And I don't recommend the tent option. Is it going to turn you into an expert overnight? No. But what it will do is it will give you a structured roadmap that you can scan through and start picking up buzzwords and begin building a model that will rapidly allow you to contribute, to at least not sound like you're a total idiot, even if you are. The goal isn't to not be a total idiot, it's to not act like one. Fake it until you make it. So again, I present this. This time I said, what would I do? I only changed 2 things in this prompt. That's the beauty of it. It basically is mostly just general structure, and you change the topic up here, domain name system, and then down here, what specific aspect of domain system. That's it. It's very simple and easy to tailor it. And this is what I ended up using this morning to answer the how do I set up a Pi-hole question. So for the example that I just gave on the previous page, which no one's going to read, and that's fine, it's in the slides, and you can, you should be able to copy and paste it. If not, you can get a variation of it out of the other materials that I provided. And keep this. This is going to be something that you can use over and over again because it's basically just a template you fill in a little bit, and it's quite surprising how effective it is. And so it always prompts you to explain what you want to understand at the end of it. And by breaking things up that way, what you usually will get, this is what I got from my experimental run against 5 different models doing 6 different responses, was they'll give you some sort of structured general framework, and then you answer that question, and they go back and they revise the framework to fit your particular goals. What I found fascinating about this is when I asked about how to set up the Pi-hole, the answers I got were radically different. Not in terms of the basic concepts, but in the way they were presented. And so the lesson here is use multiple tools and find the one that works best for the way that you learn. One of them, Kimi K2, has a new OK Computer functionality, which I used, and it generated pretty pictures, like graphics, literally HTML. So you load them up into the web browser and suddenly you have a visual, and some people are visual learners. Some people don't learn well from text. Maybe you're a person who prefers auditory signals, in which case then you can feed it into text-to-speech and have a robotic voice read it to you. Although the robotic voices are getting damn good these days, so you probably won't be able to tell that it isn't actually Donald Trump telling you these things. So the learning system output is there. It's linked in the slides. And the original worksheet, which was for this class when it was supposed to have been last Tuesday, which no longer applies because we moved everything around and reordered it, is still there because there's some interesting content there. No one will look at it, but it's there for you in case. All right, so one of the scariest things about building these lectures is that now that I've started looking for exploitation in things, that's all I can see. It's like, what is DNS? It is nothing more than taking a name and converting it into a network address. That's it. How do you weaponize this and turn this into something that we can use to surveil people? And it turns out DNS is probably even more effective than the other techniques that we've already talked about. Some of you don't live on campus. Some of you live off campus, and maybe you have your own ISP. How many of you ever think about what service you're using to convert domain names into IP addresses? And that's what they're banking on. They're counting on the fact that most people don't even think about this because it's infrastructure. What has happened over time is what started out as a very simple translation service. I mean, there are parts of the DNS protocol which I was involved in, their development and their use. There are specific record types that were added for projects I worked on. They haven't added very many, well, I think they've added one or two new record types. Mostly these days they just use the freeform text field, the TXT record. But there's an AFSDB record in there, and I worked on AFS, the Andrew file system. So I remember the days when all of this was just simply a name lookup system. But then we introduced NAT firewalls. And someone said, you know, the problem with a NAT firewall is that you're at UBC. I can't tell you apart from anyone else just based upon the DNS request. But what I could do is I could build a new protocol that allows tunneling extra information through that. And then I can reassociate it with your device. Now, that isn't the way the protocols were originally motivated, but that's the way they end up being used. So now, even when you're sitting there behind a firewall and all of these other protective layers, what is happening is your information is still leaking out. The topology of your network is leaking out. So who sees those queries before your API even runs? Because remember, before you can invoke any API, you're going to have to translate a string name to an IP address. And that can be an IPv4 or IPv6 address that can be geolocated. The answer can depend on where you're asking from. When I was doing the Las Vegas skydiving work, I specifically used a VPN to proxy and set myself to look like I was coming from a particular location so that I would get what somebody in the Las Vegas area would get when they searched for skydiving adventures in Las Vegas. And I moved myself around and repeated the same searches on Groupon and found that I got different results depending on where I was located. Even when I was searching for Las Vegas skydiving adventures, if I was in Atlanta, I'd get different results. A very simple refresher. If you need more detail than this, I strongly encourage you to look at the learning output that I linked to, or better yet, take that prompt, plug it in to your favorite LLM, and see what it tells you. So the way this actually works is that on your device, there is a resolver library. It hasn't really changed very much in I don't know, like 40 years. Maybe a little bit to deal with IPv6 addresses, but the fundamental technology, the basic approach, doesn't really change. So an application calls getHostByName. And what it does, getHostByName is the traditional low-level name for translating a string name into an IP address. And then the getHostByName call will actually return to you a list of IP addresses. That's the big change, right? We added other types of IP addresses versus just IPv4, even though mostly we still end up using IPv4. But that little library doesn't actually have any data in it. It's stateless. So it calls to something upstream. It calls to a resolver. Now, you might have a resolver process running on your computer. That's not an uncommon model because you're looking up the same addresses over and over again and caching them even across applications. Perfectly reasonable. We do caching because there's a lot of locality of reference. We do the same thing over and over and over again in computing, and we are going to take advantage of that. But the DNS system itself is quite large, and it is dynamic. Not radically dynamic, it doesn't change all the time, but oddly enough, when you change it, you want the change to propagate quickly. There's nothing worse than changing a name to IP address mapping and having to wait 4 hours while it propagates. That happens, but it makes testing things more difficult. Furthermore, during the propagation delay, what will happen is different people will get the old answer than get the new answer. Sometimes you might get the old answer with one program and the new answer with the other program. And you're like, what? Because everything is cached, and the cache requires a period in which either answer could be returned. Eventually, the old stale answer times out, and you won't see that anymore. So maybe you're using your ISP. That's kind of the normal default that most people use. They trust the piece of hardware that their ISP gave them, because it couldn't possibly be the case that your ISP wants to be able to tag packets that you send through via the VPN relative to domain names that you just looked up. No, couldn't possibly be. They do that. That's how they can actually associate your activity with your device, even when you're working through a VPN, because they know what you just queried. And there's a small amount of information that is always exposed, even when you're running through a VPN. You can actually build an entire tunnel, in which case then it's much harder for the ISP to see anything because the tunnel is persistent. But most of the time, that's not the way things actually work. Eventually, we go through a series of steps where we talk to farther and farther away resolvers until we find that there are a set of, what is it, like 17 or 18 now, authoritative domain servers. They're called A, B, C, D, E, F, G, H, I think. Is that 13? I don't know. They're not very creatively named, but they've been called that for a long time. And part of the reason that this structure exists is because we have to have a static mapping for at least one of them. And generally, we have a static mapping for all of them. So that static mapping of a.hostname.com or whatever it is. I don't even remember don't remember exactly what that structure is, but at any rate, they are the authoritative domain servers. They don't get hit very often because a lot of things downstream from them cache, but they do get hit periodically because everything except for them is non-authoritative. Well, sort of. They really only provide authority to top-level domain servers. So, .com, .org, .edu, .ca, .uk. And when you query ubc.ca, what happens is the .ca authoritative name server will say UBC is controlled by a particular machine or set of machines. So you need to go ask them. Those are actually called the name servers. In the DNS parlance, those are NS records. So they tell us who owns ubc.ca. The top-level domain resolvers define that. When you register a domain with Namecheap, because they're called Namecheap, they must be cheap, right? No one would ever lie. And so you register a name with Namecheap, they then become your registrar. They control the information that is associated with your domain name. So now when I go to Aki.com, because my friend Aki created, an Aki.com, my web browser, or my tool, my utility, my application will actually go and say, who's controlling Aki.com? It will be told to go over there. It goes over there. It says, I need to know who's the authority for this. So there's a startup authority record. That's who tells me where the name servers are. I go to the name servers and I say, okay, I need to find foo.aki.com or www.aki.com or whatever. Doesn't matter. And those name servers are now responsible for giving that to me. But again, this is all done through a series of relay proxies. this multi-hop thing can get expensive after a while. So one of the tricks that people play is that they have very large caches. So if you use 8.8.8.8, anybody ever heard that IP address? That's Google's. It's their, that is their DNS service that you can use. And it has a very large cache. And it allows Google to watch what you're accessing. Enhanced DNS provides additional structure about the original requester. And this is part of what I was saying, is that they added this. There were very legitimate reasons for adding it. It's an internet RFC, but people have figured out, hey, I can use this to associate it with a particular device on that network. So I can see where the packet is going, but then I get some information about where it's supposed to go once it gets there inside of the internal network. And now I can use other information that I've gathered about you, such as your device ID, and now I can associate that lookup with your device. Route 53 is a general purpose domain name service that Amazon provides as part of AWS. There is an equivalent in Google Cloud Platform, Cloud DNS, and for whatever reason, Claude didn't want to bother to looking up whatever it was for Azure, but Microsoft has the same exact service. So AWS, GCP, I put links in there to the actual services so you can go see. Not only did they provide you at the top, those are the links to the DNS service, and the bottom one is the link to, and now how do you actually use that information to figure out what people are doing. So you want DNS services, you pay for the top one. You want to use the information about who's accessing your services, you pay for the bottom one. So an ISP resolver gives you the full the IP address, a timestamp, the full domain of what we're looking for, and your geolocation information, which usually is inferred from your inbound IP address. Public resolvers, like the first one is Google 8.8.8.8 and 8.8.4.4. CloudFront is 1.1.1.1, and they use information from those queries to build a better understanding, not of just you. They do aggregate information here as well. But they can also identify then threats. We were talking about proxy services and VPNs and whatnot. One of the common problems when you use a shared VPN service is that some people are doing things that are malicious. And you will find that you get blocked, like when you try to access Google. Sometimes you will get blocked because other people have been using the same IP address to do malicious things. And so they've been tagged and they break things. Managed DNS providers, which is essentially everyone who provides DNS services, gives you control over the mapping, but then also provides you with these telemetry tools. How do you benefit from that? It turns out that ISPs, I don't know why it chose US ISPs, probably because it's a US model. I guess I should be using Cohere more because that's a Canadian model. They actually package this up. It's a service. They sell to advertisers. Hey, we can tell you who's looking at your site. We can tag things. Have any of you ever had like you go looking for something on Temu, and then the next day you're getting ads from other services for the same exact thing? Well, this is what's happening. This is how it's actually being accomplished. Now, this is great. I mean, if you're building applications, you're trying to figure out how to pay for them, now you have another channel for monetization. That's awesome. Do you see why this is starting to make me very cynical? Even more than I was when I started this class. Every time I look at anything in cloud computing, I go, it's just about scraping more information about us and selling it in different ways. Data brokers use this information to build profiles, so they can build targeted ads. They can focus on talking to us. Now, I haven't really gotten, and I will touch on it just briefly because I don't want you guys to have nightmares about it. There was a company called Cambridge Analytica. Has anybody ever heard of Cambridge Analytica? Why? They provided a commercial service that allowed specific targeting of material to individuals. I mean, they were able to target at individual levels. And it was used and marketed by them as a means of manipulating people. And you go, oh my gosh, that's just so awful. The reason it was called Cambridge Analytica is because in the early 2000s, I think it was around 2004, 2005, maybe a little later. I'll look up the dates when I put the talk about it. A couple of PhD students took a standard psychological profiling quiz and they put it on Facebook. And they were PhD students at Cambridge, the university in Cambridge, England. Not the Cambridge where Boston, where MIT and Harvard are. And they didn't really expect to get much out of that. They're PhD students, they're barely older than you guys are, and they hit pay dirt. They got millions of responses because the psychological profile would tell people something about themselves. It also told these two PhD researchers a lot about the users. They ultimately were able to develop a model by which they could predict more about your behavior than you could predict yourself, just by having, I think it was like 200 or 300 likes on Facebook. In the days when I used to use Facebook, my algorithm became like everything. Why? Because it meant the algorithm was basically broken. It couldn't do anything with that. I just liked everything. Even now, today, when I go on Instagram, I like I'll go to about the 5th ad, and I'll like everything that's not an ad, because I don't want them to actually have that data. Data brokers build these profiles. They build targeted ads. A lot of this is just simply because they want to sell you something that they think that you need. But Cambridge Analytica went one further. They said, we can manipulate people's opinions and how they vote by giving them targeted advertising. And the beauty of targeted advertising was that no one who wasn't targeted saw what was going on. See, when I take out a bulletin board ad, everyone gets to see that bulletin board ad, including people who think that it's complete bullshit or people who think it's absolutely the gospel truth. If all I do is take people who are borderline and push them to the either complete bullshit or the complete gospel truth side, the people who are outside of that set don't see it. They don't even know that there's this manipulation going on. And that is why the monetization of building individual profiles of users is so powerful. I mean, remember when we started with link shorteners, it was a great idea. The person who said, I need to put these on Twitter, and Twitter only allows me 120 characters. I think it was actually I think it's always been 120, because whatever it was the maximum length of a text message, which itself, in case you don't know, a cell phone text message was originally added as a debugging channel. Turned into a very profitable debugging channel. There was a time when you had to pay per text. And it was just something that already built into the protocol. So in order to maximize your utilization of a tweet, what happened was people created link shorteners so they could put links in there. Perfectly legit. And then we went down that path of, okay, now how do we start paying for this? How do we monetize it? How do we use it to track people? And it's just this recurring theme over and over again. People actually use this for security products as well, because of course, once we've identified that you're a bad guy, we can watch what you're doing. So it's not like this is just about monetization, although I would point out those security products are charging someone for that intelligence data. But DNS actually allows us to infer information. You know, if your partner searches fertilityclinic.com, then we've learned something about you because we know something about what a search of that means. Maybe you're surfing to xhamster.com. Somebody's laughing. They know what xhamster.com is, right? It's like, yeah, okay, Pornhub, those kinds of things. They can begin to put together a profile. Based upon the websites that you visit, they can determine what your sexual proclivities are. They don't really care. I mean, the people who are actually monetizing this, they don't really care. What they're really trying to do is figure out, what can I sell you? And who can I sell this information to so they can sell you something that you want? There's a really cool instance where Target figured this out years ago. This is before LLMs and whatnot, but even just in data science in general. Target in the United States, which was here briefly in Canada and then failed, like many US companies do, found that they could actually predict when a woman was pregnant based upon her purchasing behaviors before she knew she was pregnant. And they would start sending her maternity-related advertising. And there was a case where a guy got really upset because his 16-year-old daughter was getting this stuff, and he's like, he sued them, and he lost because it turned out she actually was pregnant, and she didn't know it, or she didn't want to tell him that. It's really in the cloud that DNS has been so effectively utilized in this fashion. So in AWS Route 53, they give you lots of abilities to control things, and it turns out that all these things are actually quite useful. So you can create resolver endpoints, and you can create logs of who's querying for these domain names. Where are they coming from? What are they doing? So now this is your set of domain names for your company. And you watch what people are tagging and how they're finding you and what names they're using. And you get to combine this information, the DNS level information, then later with the information in your web server's logs that say this is what they looked at. See, it's not the individual piece of information that's valuable, it's the ability to connect them together that creates what I'm now describing as a rich knowledge graph of individual behaviors. What you do, and what you do, and what you do. So let's talk about this. How do we keep track in our own applications of what we're telling our users? Because remember, we're building an app. We've told our users what kinds of things we'll do. Maybe your terms and conditions say, we're going to keep track of you, and we're going to sell your information to other people. How many of you go to a website, and the first question it asks you is about cookie policies? And what do you usually click? I know what I usually click. I normally, if I'm in a hurry, I will click reject all, but usually I'll go in and I'll set custom ones because I'm like, no, I want things that will improve my experience, but I don't give a rat's ass about you collecting data you can sell to third-party providers. But they ask every time, except when you click accept all, when they just won't ask you again because they got what they wanted. It's like WestJet converting their airplanes so that they can no longer recline unless you pay for seats that have reclining ability, right? They sell inconvenience. Well, upgrades to inconvenience. So they make inconvenience the default and they sell the upgrade. Just pay us with your personal data. So when you think about this and you're building apps, what is the promise you're making? If you read some of those terms and conditions. We didn't read the terms and conditions to say what can they do with your data, or maybe some of you did, but you should. And when you're building these apps, you need to keep that in mind. Maybe somebody was foolish and wrote a nice user-friendly license agreement that said, we're not going to sell your information to third parties. Has anyone ever heard of a company called 23andMe? Does anybody know what kind of data they collected? Sorry? Genetic information, details about your genome patterns. It's not a complete genome mapping, but it was a significant genome mapping, and it will tell you about certain potential conditions that you might actually have. And along the way, they ran into a small problem, which was they couldn't make enough money. So they changed their terms and conditions. And the terms and conditions gave them the right to monetize that data. I never logged in after that. Because in order to get your data removed, you had to log in and agree to their terms and conditions. And those terms and conditions would have given them the very rights that I wanted to take away from them. So now we're in this limbo where 23andMe has gone bankrupt, has been acquired by someone else, then we can only hope that they will respect the privacy rights of the customer base. So the promise you made, we saw that in the flow data case, it was very obvious. The technical implementation, how are we going to make sure that promise is obeyed? And then the failing test. We start with a case where we're not obeying. We make sure that our test works, so that way we at least have a hope that it will catch when somebody else comes along and goes, oh, this is stupid, I'm going to take this out. It's cheaper to use services in Botswana than it is to keep them here in Canada. How many of you were here during COVID? UBC required that you upload proof that you had your COVID vaccination at one point. I'm the troublemaker who actually went and looked at the company they were outsourcing this to, and do you know they had exactly 0 IT security people as part of their corporate structure? It was all doctors. I refused. I said, I will not do that. I will not give that data to them. I will not give it to a third party. I'm happy to give it to UBC because you are legally bound by laws that that company isn't. And eventually UBC accepted it. My guess is they probably uploaded it to that third-party company anyway. But that was UBC's decision. That's why clause control test is important, is because now you make sure, if you're working for the company that's gathering that information, you make sure that the correct safeguards are in place. And this is just one more place where we build these safeguards. If you have a clause that says this data must be stored in Canada, your control is that you set up your Route 53 outbound mapping to only go to Canadian forwarders. And now what you do is your test is you try that across domains. You try to forward it to a European domain server. You want to make sure it gets rejected. Just an example. NX domain is in fact the indication that that domain is not available from the server you're using. If you have a log retention limit, DNS logs are purged after 30 days and access requires MFA. Does anyone know what MFA is? It's not a master's in fine arts, I can tell you that. I bet every one of you has used MFA. What is it?
Multi-factor authentication.
There we go. There we go. He's going to be the security person. The rest of you are going to be the product. Multi-factor authentication. You know, Google Authenticator, Microsoft has an authenticator. Anybody play games like with Steam? What is SteamGuard? Besides annoying. It's a multi-factor authenticator. It means something you have that's in your physical possession. There are these things called passkeys now. which are basically encrypted cookies that require biometric identification techniques to ensure that you are who you say you are. So how do you implement that? Your control mechanism is you look at a lifecycle policy. You make sure, so there's two things you're trying to make sure of. One, people who access that do have multi-factor authentication. So you set up a case where somebody doesn't have multi-factor authentication. And you make sure that initially they did have access, then you added the control in there, now they don't have access. So now you know your test is working correctly. I'm going to actually skip this, and this is the thing, because this was supposed to have been done last week on Tuesday, but I left it in here anyway because I still think it's a generally useful exercise. Instead of doing this for Project 2, think about how you're going to do this for your capstone, because I haven't given you Project 3 yet, because we're in the middle of the Project 2 review cycle. But it'll be good to think about it within the context of your capstone pitch, because you're already starting to think about what is it I want to build, and you should also be thinking about how does DNS fit into this? How am I going to use this to make money? So you know what I should have done? Instead of giving you like a $500 limit, I should have said, but you're allowed to offset it by the income that you can generate. That would have been a more interesting exercise. Maybe I'll do that for Project 3, just to up the ante, make it more interesting. So, what are privacy-focused alternatives? It turns out that this is a well-understood and well-known problem. Does anyone know what TLS is? Transport level security? Whatever. Does anybody ever use HTTPS? Okay, well then you may not know what TLS is, but it is the mechanism by which we build secure hypertext transfer protocol connections. So TLS used to be called SSL, Secure Sockets Layer. TLS is the mechanism by which we encrypt traffic between your device and the other end of that connection, which could be the server that's providing the service, or more likely, it is going to be an ALB that's sitting in the front end of your cloud provider who has the keys, decrypts the traffic, and then sends them internally to the actual server that's implementing the functionality. I know that was a mouthful, wasn't it? I'm going to actually save that one because I'm going to talk more about that later, because I think it's worth going through talking about how security is implemented. So for DNS, some people have said, this is ridiculous. We need to set up alternatives that don't allow people to monetize us, but still give us the benefits of having caching servers. And so there are a couple. There's a Quad 9, which uses 9.9.9.9 and is a nonprofit that doesn't log and uses DNS security. DNS security provides protection against people spoofing, because it turns out that DNS hijacking is a profitable venture for criminal organizations, criminal enterprises. NextDNS is not a not-for-profit. They do have custom policies. They do have encryption, but they don't actually have paid tiers, so it leaves the open question of how are they monetizing this? How are they paying for it? The ISP default is, in fact, okay, well, you guys can just do whatever you want with my data. That's the accept all option, and that's the default. The way that eDNS can leak your data is that it includes information about your internal info. And the reason for that is because you go to a resolver. That resolver maybe is in your gateway. The ISP gives you this gateway. So that resolver is going to get an answer, and it needs to know where to send the answer back to the original client, because it was your phone that was asking for that IP address. Your gateway doesn't know it was your phone, and so it knows because we can embed that information in the actual request itself. So we just forward the request, it comes back 2 days later, we look at it and go, oh, it's intended for your phone. The 2 days is slightly a joke, but sometimes it takes a while to get DNS resolution. And the benefit to this architecture is that now your ISP knows which device it is within your network that made that request, and we can correlate that against the other activities that you've been engaged in. So not only do you go to xhamster and familyplanning.com, but you also go to Temu. And you visited the WestJet website as well. Where are you thinking of going? I mean, we can't read inside the connection that you've got to WestJet, but we can go to WestJet and we can say, hi, this entity talked to you. Can you tell us where they were going? And WestJet can go, sure. They wanted to go to Calgary. That's what data brokers do. They put the pieces together. They build these maps. As you begin to use more than one cloud provider and you traverse across different cloud services, because no one just simply hits one service when they're building their app or their web page. They hit dozens of them. A couple of you have a laptop open. Go to some page, go to Amazon.ca and open it up and look at the page. I don't know how you do it on the Mac, but on a Windows machine you have Control-U, and it will show you the code, the actual HTML code, and you start looking at all of the URLs that are inside of that, and you're like, what the heck is going on here? You hit a lot of different sites. Why do you think it takes so long to load a web page? So each time you go to a different resolver, and you're going to dozens of them, you end up exposing additional information to them. And eventually what will happen is some data brokers will put that back together. I already pointed out to you, if you go to YouTube and you do a share this video, most of the time it will have an SI equals. So it'll give you the URL to the video and then a slash, a question mark. And the question mark indicates everything after it is a parameter. A question mark, and then SI equals. And the SI equals is how Google knows you recommended that video. I strip those out. When I give you links to videos, I go and I strip those out, because I don't want Google to know where you got them from. It's a very small thing, but it's my rebellion against the corporate surveillance environment. Law enforcement actually has, interestingly enough, mixed access to DNS logs. The Canadian law enforcement is very unhappy because there were recent decisions like 2024 that said that they actually can't get to those logs without a warrant. And there are already proposals to change that. So I actually linked to a current proposal. Not adopted, it's just a proposal, but there are people who are actively saying this is causing us problems. In the US, they have no problems. So if you use any US sites, and now nobody would need to use that, right? If you use any US sites, then of course US law enforcement will have access to that. And I will tell you, based upon personal knowledge and experience, if the US has access to it, CSIS has access to it. Because the US and Canada have extensive data sharing arrangements. This is how they spied on each other's citizens. Because both countries have laws against spying on their own citizens, but they don't have laws spying on the other one's citizens, and then they just swap data, which effectively means they're spying on their own citizens, but they didn't want to admit that. Anybody know what CSIS is? One person knows what, a couple guys know.
It's kind of like CIA for Canada.
Yeah, I'd say it's something between the NSA and the CIA, yeah. How many of you have ever actually applied for, I don't know, permanent residence, a study permit in Canada? Well, then you're lucky. CSIS also vets all of those people. Actually, I had a friend at my gym who he eventually got transferred to Lahore. And it turns out Canada has 2 official locations in Lahore, Pakistan. And he lived in the second one. It was basically a small encampment, and that was his house, his home. So there was the main embassy, and then he had the secondary place. But he did a lot of background checks for people trying to immigrate from Pakistan, and he was talking about how it took years, literally years, for them to do background searches because it was so hard to dig up information and make sure that the people who were applying weren't undesirables. So these things really do exist. They really happen. I've actually had friends who worked for both NSA and CIA and CSIS for all that. Yeah, weird. And I've taught classes at the NSA in a vault. If you've never heard of what a vault is, in that case, it's actually a isolated, enclosed room. Literally, there's no electromagnetic interference from inside or outside, with people whose badges only had their picture and an identifier, no names. It's a very weird experience. And then later to realize that some of those people actually had been building software that you find out about, the Equinox group, which is an NSA group. I'm pretty sure I taught a bunch of those people. It's very good job security, though. They take very good care of those people. And of course, you can do real-time monitoring as well. So you can actually watch what trends are occurring inside of DNS usage. All right, we've been talking about this more. I'll leave it in the slides, but I don't want to spend too much time on it. DNS encryption was actually interesting because it was supposed to help us minimize this, and in fact, it works great until you start using a cloud-based DNS service, at which point then they have the ability to decrypt it, and they have the ability to figure out everything that was inside of the packet. So it means that if you're talking to Google, you know, you're doing 8.8.8.8, 8.8.8.8.8. If you're talking to Google, then Google still gets to see it, but your ISP can't see it anymore. So it's not a perfect solution. So DNS over HTTPS protected you against your ISP, but gave everything to Google. And I don't think that was the original intent, but that's how it actually worked out. So when you're thinking about your capstone project, because you're doing your pitch now, and then you're going to be thinking about your design moving forward, think about how does DNS fit into this? Who benefits from the DNS information in your design? Are you benefiting from it? Is someone else benefiting from it? Are you leaking it? So the party who's benefiting from it you don't recognize, you don't know? Who are you exposing? Now we're back to empty chair again. I can put the chair up here if it would help, but I think that has lost its impact. And now that you know about this, how will it affect the way that you think about your projects moving forward? I mean, I'm kind of hoping you don't end up with this deer in the headlights look of going, oh my God, all I'm going to do is leak data and make people's lives miserable and I can never write anything. Because that's not true either. Or maybe you're like, ooh, this is cool. Tony's teaching me how to like actually build a multi-billion-dollar empire. I can be rich beyond my wildest dreams. How many of you hope to have $1 billion at some point in your life? I know at least one undergraduate from UBC who has accomplished that dream. I don't know if it was his dream. He didn't sit in this classroom, though, because this classroom didn't exist. And again, we'll go back to the empty chair framing, which is, who is being affected by this? Because it's not just affecting the person using your app, but it's affecting the people associated with the person using your app. So DNS is this, I mean, I sit down, I look at this, and I'm going, okay, I'll just talk about DNS, and then I can just do it like a 317 style overview of it, and then I'm like, but wait a minute, it really has turned into yet one more way of keeping track of us, and okay, great. How can you use that in your app? Maybe that's the way I need to phrase this. How can we build this really cool app that tracks everything that people do? How many of you have a smartphone? And how many of you didn't raise your hand but are lying? The smartphone is the best GPS tracker ever invented. Not only does it keep track of where you are, it keeps track of who you're around because it can see the other signals of the other devices you're hanging out with. It knows what you're looking at. It knows who you've been emailing, what websites you're visiting, what apps you're using, it's got your bank account credentials, everything. It's pretty cool. And this is just examples of what happens. So if you're hitting LinkedIn at 2 in the morning, maybe it's because you're job hunting. I hope none of you are hitting LinkedIn at 2 in the morning, but as annoying as it is, LinkedIn turns out to be a way that people still use to find jobs. Of course, we use AI to generate customized resumes for target companies who then use AI to filter them out, neither of whom will ever actually talk to each other. Right, so you apply for a job and you never hear anything from them again, or somebody sets up an interview and you just don't show up because you're not interested anymore. It's the way of the world. I like the WebMD and pharmacy one. Gee, you got some sort of health issues you're worrying about. You're going to go talk to Dr. Google, or Dr. Bing, I guess. That's the cheap one down the street. Realtor.ca and tdcom/mortgage. Maybe you're house hunting. You're feeling particularly rich right now, or you're looking and going, well, okay, so I can see this trend. I've modeled it with ChatGPT, and what it says is that over the next 12 months is the optimal time to invest in real estate, because after that, the supply-demand curve will shift again because I stopped building new houses. Maybe you haven't done that analysis yet. Probably not, but some people are. As you go around Vancouver, you will see there are still cranes in the air. In 2 years' time, you won't see very many cranes in the air because they've all stopped the planning building process. How long does it take to build a new project here in Vancouver? Anybody know? About 10 years. Last time I checked, and these numbers do change, the cost just of the city's fees for building a new building in Vancouver is up to about $600 a square foot in the city. That means a 1,000 square foot apartment is going to be $600,000 just to the city for all the costs associated with that. So that 1,000 square foot apartment is going to be $1.5 to $2.0 million. So of course you're watching that. You're sitting there going, how can I arbitrage this? How can I make money on it? How can I become the Zillow of Canada? There is no equivalent. The US has Zillow, which basically gives you valuations of pretty much all the properties in the United States. And there is no equivalent of that here in Canada right now because of regulatory capture. The data isn't easily available. Someday somebody will break that regulatory capture somewhere, and then they'll make a lot of money from it. Or divorcelawyer.com, I like that one. Gee, you're having relationship problems. Okay. Of course, now that's not the way you deal with relationship problems. Instead, you sit there and talk to ChatGPT about it. And of course, OpenAI wouldn't be using that information to then begin feeding your ads with divorce lawyers. Software as a service is interesting because in software as a service now what we have is multi-tenant. That's basically what everything in cloud is. There's multiple different distinct users sharing common resources. They have a shared DNS resolver and all the queries get mixed together. And so there is leakage of information as well inside of the cloud. What can you do? Make sure your project DNS dependencies are well understood. Make sure that you use privacy-focused resolvers, and make sure that you have adequate testing to make sure that your DNS level guarantees are being implemented in your implementation. And now I'm going to give you just a tiny ray of hope that you can personally implement with a minimum of resources, because everyone in here is running a supercomputer on the desk there. The first supercomputer I ever saw was at UC Berkeley, and it had a bench around it. Literally, there was a padded bench around this Cray 1, I think it was a Cray 1 XMP, and it was huge. And it was probably about 8 feet wide. It was completely circular. Well, it was open at one end, but it was circular, and there was a bench around it. You could sit at. And what you can do with the device in your pocket now far outstrips what that very, very expensive, very specialized computer could do in 1988. You can build your own DNS resolver at home. You can do it on your laptop. You can put this into a container. It's very easy to containerize the Pi-hole software. Pi-hole is a DNS resolver that also helps thwart advertising. If you've ever noticed how slow it is to load web pages or apps that have web pages that are built just nothing more than wrappers around web pages, because they're loading lots of advertising content. So one traditional approach to this is to use a browser that blocks advertising content. And the problem with that is that advertisers can figure out when you're blocking their advertising content, but they can't detect when you're blocking the domain name system's resolution of the location of the asset they're trying to put on the page in the first place. In other words, it's foo.cloudfront.cdn.com. I'd say foo.cdn.cloudfront.com. There you go. And that's where some picture or some advertisement is actually hosted. And what a Pi-hole will do is that when your device goes and says, what's the domain name for that, it gets back not found in X domain. And so the web browser just leaves an empty hole. And empty holes with no data in them load faster. I recently told a friend of mine to start using, or to try out Comet. Comet is a web browser. It is the Perplexity web browser. When Perplexity literally offered to buy Chrome from Google, it's because they wanted to take Comet and take its functionality and merge it with Chrome. And Google, of course, turned them down because the Google web browser, Chrome, actually is extraordinarily profitable for them because it gives them a lot of data that they can use. Comet blocks ads. Try it. And what you'll find is that suddenly surfing the web is a lot faster than it used to be. A Pi-hole does the same thing, and it can be extended all the way to every device in your network. It's a very simple approach. And if you really want to learn a little more about DNS, it's not a bad way to do it. It's pretty straightforward to maintain. But I went one step further. I said, okay, I'm throwing this thing at my students. How do they actually go and operationalize this? Because you guys are drinking from a fire hose. So I said, what can I leave as an artifact that you can use during Christmas time, the winter holiday break? During the winter holiday break, what could you do when you're bored and you're like, oh, wait a minute, that could be fun, and you just grab it and it'll be there for you. Or when you actually care about your own security and you say, how could I harden my network because I'm tired of having my identity stolen or whatever. So here you go, learning prompt. And of course, this also reinforces the learning prompt lesson. But I went one step further. I did this morning. I said, take that prompt and feed it into different models. And so what I have given you as an artifact here is PDFs that I generated from the conversations, and they're identical conversations that I had with 5 different models, including Kimmy. I used both the OK Computer mode, which gave me pictures, HTML, it's very interesting, as well as the non-OK Computer mode. And there's one that I left out here because I figured it was the one that's most likely for people to already try and use, and that is I left ChatGPT out. But what I found really interesting about this is the answers were different even though the questions were identical. They weren't radically different, but they were different approaches to answering the same exact scenario. And so now here you have it. I've done the work. I've generated the PDFs. I have the markdown files if you really want them. But I generated the PDFs. The PDFs are there. You can literally hit the complete bundle link and it will give you all of this stuff. The 3 pages that Kimmy created, I put on Canvas, and those are links to the actual Canvas pages. So those are like very low-hanging fruit kinds of things. You can literally click on them and say, oh, what does this look like? And you'll see the pretty picture version that Kimmy put together. They were all credible. Afterwards, I didn't include this in my analysis. I asked Gemini, I said, one of my concerns with this is that this creates a high cognitive load exercise. I'm basically throwing a huge amount of information at you. And Gemini's recommendation was you don't look at the detailed map, you just look at the first high-level bullets. And my recommendation is skim these. Don't spend your time trying to actually work through it. These things are laid out so like you can work on this project for 8 weeks. Don't trust AI scheduling. You know, you will ask AI about doing a project. It will tell you this is week 1 activities, this is week 2 activities, this is week 3 activities, this is week 8 activities, and 20 minutes later you're done. Did anybody get a chance to use SpecKit? I might have asked that. So here's my observation about SpecKit. The right way to use SpecKit is completely the opposite of the way that you've been taught to write code. Instead of trying to fix bugs in the code, you figure out what the bug is in the spec. You fix the spec, you throw the code away, you regenerate it. It's actually faster. And that is not the way that they've been teaching you how to build software, is it? You write the tests, you use the tests to fix your debugging of the code, you fix the code, you try to preserve the history of it. This is like, no, sorry. What you'll actually find works better is to realize that the spec is what's important. You write the spec, and the code is, in essence, your test to see if your spec was well written. And sometimes, even though the spec is actually pretty good, the code that it generates is just crap. And in that instance, throw it away and do it again. And you know what you'll find? You get a completely different implementation. It's so weird. It's the realization, a couple of you were in the class before this, right? So they're talking about natural language programming. It's like I said last Thursday in that rambling lecture I gave. These things are infinite probability spaces and they collapse when you feed them a finite length input string into a continuation. Over the weekend I read this paper that suggested that you actually, instead of, so like when Claude asks me a question, instead of telling Claude what I want it to do, I ask it to give me back a list of the 5 most probable completions to its own question. I have it do it in a task, in a sub-agent. And what's fascinating about it is it suddenly does even more thinking for me because it will list things that I hadn't necessarily thought about, or sometimes ideas that I kind of flitted around in my head will show up in that list. And it's like, wow, this thing really does actually do possible completions. And what this is mapping out for me is not just the highest probability one, but things that are possible, but not as high on the probability scale. That was a very interesting paper, and I've been operationalizing that very quickly. I think that's the worst part about talking to or dealing with AI is that the landscape keeps moving very, very fast. And the nearest analog I could find to this was, I think I used this example before, electrification. Going from no electricity to electricity. How many of you have actually gone camping where you didn't have any electric? How many of you have actually been to a place where you didn't even have phone service? Did you turn your phone off? Yeah, it's basically what? A glorified watch. That's a different world. It changes your perspective when you stop having electricity. So it's hard to explain what it's like for someone who made that transition, but that is in essence the transition. Oh, it waited until this long. I forgot to put the power switch on. That's the transition I think we're in right now. Now, some of it's complete bullshit, too, because I saw a video where people were talking about the singularity, how we're already in the middle of it. And one of them said, well, you know, the Open Erdos Questions website has had 24 updates in the last couple of weeks by ChatGPT. And the person was saying, well, that's because ChatGPT is solving these problems. And it turns out that, in fact, ChatGPT is not solving the problems. ChatGPT is finding people have solved the problem and is pointing out that they are solved. And if you don't know who Paul Erdos is, then you're not a mathematician, because he was one of the most prolific mathematicians of the 20th century. I think he's dead now. I'd have to go check. But for quite a while, that was a measure of how important or influential you were as a mathematician, was what your Erdos number was, i.e. how many papers you had to go through to get to a paper where he was a co-author on. And he was writing like 200 pages, or 200 papers a year, 100 papers a year. It was an insane number of math papers, because he traveled around and he worked with lots and lots of people. So at any rate, so that's my offering to you, is this whole conversation. This demonstrates the use of the structured learning prompt, which I know you guys are in the middle of doing things, but you might try this for your other classes, unless they prohibit the use of generative AI for educational purposes. But I encourage you to do that here as well. How many of you have actually used Gen AI to do your capstone pitch? Why didn't you? You didn't raise your hand, so I'm assuming you didn't use it. Sorry? Oh, you did. You just didn't raise your hand. Okay. Well, and I picked on you because you're visible. I should really pick on the people in the back row, but they've all decided to go to Cancun. Who hasn't tried it? How beneficial has it been? Tell me one way it's disappointed you and one way it's surprised you. As a group, not individually. Interesting. So it remembers across your conversations. So I think I mentioned last week that the only model left that wasn't doing that I knew of was Gemini, and over the weekend they added memory to Gemini. You noticed? Yeah. It starts to know, and it's very weird how they're all following each other. Kimmy has it as well. Although I had an interesting conversation with Kimmy over the weekend about why it presents things differently, and it actually says that its training is to minimize harm, not to please users. And that's why it gives a better empty chair perspective, because it did a really good job of basically weaponizing the categorical imperative, which is the idea that a rule is only a good rule if it should be universally applied. In other words, if you switch the question, the asker, the parties of the question around, do you end up with the same rule or not? If not, then you have an imbalance. All right, so that was DNS. Thursday, I will be talking about social meeting apps. And I last week presented my sample for SpecKit, and my goal is to walk through the implementation that my SpecKit generates and talk a little bit about it. And then, because I want to keep hitting this, I want to keep showing how to use these generative AI tools, not just to encourage you to use them. Now I've got you using them, now I want to get you to a point where you can use them more effectively, because it's going to make your capstone way easier. See you on Thursday. Hopefully it doesn't snow between now and then. I don't know that it's supposed to, but we are starting to move into that time of year where snow starts showing up in the forecast. How's your side project coming?
How's my
Side project, your startup idea.
Startup idea? It's going good. We're actually rolling.
Oh, cool.
Yeah. So
So you're not sleeping at all.
no, not much. But it's going good. It's like we got a lot of ideas, but it's like hard to focus on just making one thing work well.
It's very easy to lose, to lose that focus.
But like one thing we totally found. Have you used Grok Fast? That was like a big like step change for us because it was like
Were you using regular Grok?
no.
Oh, you weren't using Grok at all.
We were using Gemini Hash
Oh, okay.
because we were like optimizing for speed
Oh, okay.
in like the file placement
Yep.
part of it. But then when Grok 4 Fast came out, it was like 3 times faster. So we went from like
Did I not say that this business is moving really fast? It's very hard to keep up with.
yeah. So we went from like taking like a minute of the minute 15 to name and sort a file to like under 30 seconds, which was huge.
Yeah.
But yeah.
So you're actually using the LLM as part of your product.
Yes.
Yeah. One of the things you might actually want to do then, are you using the APIs directly or are you using?
We're using APIs.
Okay. One of the things you might want to actually try, and the reason I ended up using OpenRouter was because it allowed me to bake models off against each other very quickly, because I have a single uniform API.
Yeah.
Because you may find that you can actually get as good a results from free models as well.
Yeah. True. We've been using like Langsmith, you know LangChain,
Yeah.
to like when we have the traces,
Okay.
we can like run experiments on them
Yep.
to like try different